Hello everybody. I hope you're having a good day at home, working through your off day assignments and completing things you need to do. So for ours, I'm going to give you a little instruction here, some examples. I'd like you to watch this, and then I'll give you an assignment that'll be due as well. It'll be in the book. All right. We're going to talk right triangle trig word problems. So we're still using SOHCAHTOA. All right, so remember that you need to use that throughout solving these problems. All right, but just a couple examples and a couple things to look for in terms of a word problem. One of the things I'll tell you is definitely to draw yourself pictures of the situations if they don't give them to you. And also remember, every situation we're dealing with has to be a right triangle. So a lot of times I just start with, hey, there's a right triangle, and then try to put the information in that right triangle. Okay. All right. So first one here is kind of a basic problem. And this one we do get a picture with it, so that's helpful. All right. And the problem here is a support cable runs from the top of a telephone pole to the point on the ground 42.7 feet from its base. If the cable makes an angle of 29.6 degrees with the ground, find the height of the pole and the length of the cable. So you can see the picture below. A couple things here. Another term they might use is guy wire. Okay. That's the same thing as a support cable. And that's this thing down here that you see, this part right here. Okay. It runs from the top of the telephone pole to the point on the ground, 42.7 feet from the base. So that's why that's down there. And then the angle is with the ground, so that's why it's down here. If I would have said with the pole, I'd have been talking up here. This, of course, is a right angle. All right. So if we go to fill in some stuff here, we have to solve, what do we want to find? The height of the pole. So we want to find the pole, and we want to find the length of the cable. So, we could call that X and that Y if you want, but we also have to label our right triangle. So this is opposite, this is adjacent, and this is hypotenuse. So we can only solve one at a time. So let's find for the pole first. So that's opposite and adjacent. So that would be SOHCAHTOA tangent of 29.6 degrees equals X over 42.7. Of course, you multiply, right? 42.7 times tangent of 29.6. So we get that the height of the pole is around 24 I'm just going to go 3 in this case, meters, or not meters, sorry, feet. Okay, so the height of the pole is around 24.3 feet. Length of the cable, we can now use Pythagorean theorem if you want, 42.7, 24.3, but I'm actually going to use trig. I'm going to use...
Ian Albertson, please report to...
Sorry about that. I tried to pause it. There's an announcement going on. I'm doing this at school during the week here. So if we want to find the hypotenuse, we're going to use the adjacent and the hypotenuse. So that's cosine. So cosine of 29.6 degrees is 42.7 over y. And since the unknown is on the bottom, we are going to divide. So y is 42.7 divided by cosine 29.6. So that means y is around, when you type that in, 49.1 feet. So the length of the cable is about 49.1. All right, so if they give you a picture like that, it's, the information's already there. It's about labeling and kind of solving the same thing as what we've already done in class with SOHCAHTOA problems. All right, okay. So the next thing is kind of talk about two terms, angle of elevation, angle of depression. All right. So angle of elevation, we have this little boy in a sailor outfit. He's kind of creepy. I always find this little kid creepy looking, kind of like something out of a Stephen King novel. But anyway, he's looking up at the bird. And so when he's looking up, this dotted line is the horizontal from his eyes. We call this angle the angle of elevation. So looking up is an angle of elevation. All right. An angle of depression is the angle below the horizontal. So this is why I find this little boy creepy. It feels like he's levitating above the dog, like some weird satanic thing. So just to make it not as creepy, I'm going to put like a hill or a cliff there that he's standing on. So he's looking down at this dog, and we call that an angle of elevation. Now, what's important is it's this angle here, not this one in there. Okay, that's the mistake people make. They think it's that, but it's from the horizontal. Now, here's our right triangle. What we need to understand is, how would I find this angle that's over here? Well, one, I know this and that angle add up to 90, so you could subtract from 180. The other thing is this. Notice this symbol here and here. If you remember from geometry, that means parallel. So those two lines are parallel, so that means this angle and this angle are the same because they're alternate interior angles from geometry. So the angle of depression is going to be the same as the one down here. All right, so you can use that. The other thing is, when you're setting up these problems, you could have your triangle this way, or it could actually be set up this way as well. Everything is still the same. You know, this distance is the same as this distance, and then this is the same as that, and then you have that angle given to you. Okay, so some other things to think about when you're having problems like this. All right, now let's use that. All right, so now we have a hungry cat spies a bird in a tree. The bird is 3.4 meters above the ground, and the angle of elevation to the bird from the cat is 40 degrees. How far is the cat from the base of the tree? All right, so this may be helpful to have yourself a little picture. So we have ground, we've got some tree here, and we're going to have just a kind of dead branch there. Actually, this whole tree is kind of, I'm going to stick with the creepy theme. It's a dead tree. Okay, and so there's a bird. Let's well, you know what, I'm going to make this, I need the space. Okay, there's a bird right here. There's the bird, and his big beak. This is supposed to be his eye. It's a little off. His wings. Okay, you like my bird? All right. You guys don't have to draw as good as I do. I mean, as you can see, I'm quite artistic. So then we have this cat down here. All right. All right. Okay, and he's hungry. And let's see. So now what's important is to remember that there's a right triangle involved every time. So here is my right triangle. Okay, right angle. And now let's put the information is. The bird is 3.4 meters above the ground. So there. Okay, the angle of elevation to the bird from the cat is 40 degrees. Okay, so there. The angle of elevation is going up. How far is the cat from the base of the tree? In other words, I'm looking for this. And a lot of times, unlike the last problem, we're only looking for one thing. Okay, so in this case, we're trying to find x there. So this would be my opposite, and this is my adjacent. So which trig is that? SOHCAHTOA. It's tangent again. Tangent of 40 degrees is 3.4 over x. Since x is on the bottom, what are we going to do? Yep, we're going to divide. X is 3.4 divided by tangent 40. All right, and so we should get about 4.05. In this case, I went 2 decimal places, and that is meters. Okay. All right, so the idea there, to make sure you understand how to set it up and make sure to put the right triangle and the angle of elevation. Now, I know angle of elevation probably should go to the cat's eyes, but just to kind of keep things consistent here, we're going to put it on the ground, how things match up, okay, with the information given to us. All right, I want you might want to pause the video here a little bit, and I want you to try this one about a fishing boat that's 120 meters from a point on the water that is directly above a school of large fish. The sonar fish finder in the boat indicates the angle of depression from the boat to the fish is 55 degrees. How deep are the fish? So why don't you pause this one and try to answer it. Okay, so I drew the picture here. Now we got to make sure to understand there's a right triangle going on. A fishing boat is 120 meters away from a point in the water is directly above the fish. So this is directly above the fish. And here, so 120 meters. The sonar fish finder on the boat indicates that the angle of depression from the boat to the fish. Now remember, an angle of depression would go down to here. This angle right there, okay, is 55 degrees. How deep are the fish? So we're looking for this. So again, we have to think about our opposite, adjacent, and hypotenuse. So this is opposite, this is adjacent. So again, it's tangent. You're going to find a lot of these problems are tangent because in a real life situation, you usually can measure something on the ground or the other direction, and you can use that to find the other one. So a lot of them are tangent problems. So tan of 55 is x over 120. You're going to multiply 120 times tangent of 55. So what do we get? 171.4 meters. That's how deep the fish are. Definitely my picture is not to scale, as you can see there, but that doesn't matter, okay? You don't have to draw them to scale. You just need a right triangle, and you got to find the information, all right? Okay, one more, the most complicated problem. All right, so on the top of the castle, there's a statue of Mr. Hook. Yeah, I'm sure this is true somewhere in England or something. There's a statue of me, right? All right, the angle of elevation to the bottom of the statue is 37 degrees. At a point on the ground that is 60 meters from the base. Oops, I'll put this all the way down. From the same point, the angle of elevation to the top of the statue is 42.8. All right, so let's draw yourself a picture here. Oops. Let's do that. Okay, so we'll do a castle, you know, something like this. All right, and then there's this big statue of me. Since it's a statue on a castle, it'll probably have a sword of some sort. And a hat. With a feather in it. Okay. No laughing at my pictures. They're beautiful. All right. So we have this point on the ground. The angle of elevation to the bottom of the statue here is 37 degrees, and this distance here, oops, hold on. No, let me just do this. This distance here is 60 meters, okay? Now, the other, and this is a right triangle, okay, the other angle is here, oops, is there. Okay, yeah, let me do that again. This one is to here, and this one is what, 42.8. Now, I want you to think a little bit. What am I going to do here? Well, I'm trying to find, you know, the distance from here to here, right? All right. Well, to do that, I have a right triangle here, right? And I could find this side over here. I have another right triangle here, and I could find this side. So what am I going to do with those two pieces of information? Yeah, I'm going to subtract them, okay? So one of the mistakes people make is they look at this triangle that's kind of found in here, but that's not a right triangle, so I can't use that. So I like to separate them. So what we have is we've got two triangles. You've got a 60 and a 37, and then you have another triangle that's 42.8 and 60. All right, we can solve for both of those. What am I going to use? Well, if you're not sure, you can look here. This is O, this is A, O, and A. Yeah, tangent again. All right, now what we're going to try to find is that. So when we find y and x, then we subtract them to get the height of my statue. So we have tan of 37 equals x over 60. Here we've got tan of 42.8 equals y over 60. So here I'm going to go 60 times tan of 37 and get 45.2 meters. Here I go 60 times tan of 42.8 and I get 55.6 meters. Okay, so then that means my height is going to be 55.6 minus 45. Oops, let's erase that. Minus 45.2, and that gets me 10.4 meters. So this is a problem where there's two triangles that you're going to have to use trig to solve the opposite sides of both and then subtract to find the whole distance, because this distance here is what you see here, the whole thing. And then this distance is only this part. So if I subtract those two, what I get is that. Okay, good. So I'm going to give you an assignment. I'll post it with this. It's going to be in the bookwork here. I'll write it down here as well. But it's page 337 to 339, 17 to 20, 22, 31, and 40. Okay, and again, I'll post it here in the Google assignments as well, and it'll be due then on the due date that I give there tonight. All right. Okay. Thank you. Have a good day, everybody.